This is problem 2, part A. It says, look at the graph of f given below and consider the accumulation function a of x equals the integral of f of t with respect to t from -4 to x. And what this question is all about is it's giving you different scenarios of x, and you have to decide what the specific attributes of the accumulation function of f of t will be. So before we go on, we have to define an accumulation function. An accumulation function is a function that gives the area under the graph of a function from a fixed variable to a variable x. So with that, this is asking a of -1. What is that? So for this type of question, what it's really asking is what is the accumulated area within the bounds at that point. So from -4 to -1, we see all this negative area because all these points are below the x-axis. So our answer is going to be negative. A of -4 is positive, negative, or 0. This one is interesting because if you look at the bounds of the problem, you have -4 to x. And this is basically asking what is the accumulated area from -4 to -4. And that's going to be 0 because there's no area underneath the point. So that's our answer for this one. For all the next ones, we're going to have to be referencing our extended table a lot. It's very useful because it gives us what we need to do these problems. For example, if you look at x equals -4, is it increasing, decreasing, or flat? Well, if you can see here, that's a 0 of the original f of t equation. And as we know, zeros of our original function are flat spots of our accumulation function. So the answer here is flat. At x equals -4, a of x is concave up, concave down, or inflection point. Well, at x equals -4, you can see the line is decreasing. And what does that mean? The accumulation function is going to be concave down. At x equals -2, a of x is increasing, decreasing, or flat. Well, according to the graph, -2, right here at this point, is below the x-axis. So that means it's negative. And according to our extended table, if the original function is negative, the accumulation is going to be decreasing. At x equals -2, a of x is concave up, concave down, or inflection point. Well, at -2, you can see this line is actually increasing. And whenever it's increasing, the original function is increasing, the accumulation will be concave up. So that is our answer here. Concave up, excuse me. Now, at x equals 0, a of x is increasing, decreasing, or flat. Well, at 0, you see all this area here that's actually positive. At that point, it's positive. So, according to our extended table, our accumulation will be increasing. And at x equals 0, a of x is concave up, concave down, or inflection point. Well, as you know, as you can see, at x equals 0, that right there is a flat spot. And according to our extended table, maxes and minimums of original functions are the inflection points of accumulation functions. So what does that mean? At x equals 0, a of x is going to be an inflection point. Neither concave up nor concave down. Finally, one of the last steps of this problem is suggesting what the accumulation function would look like compared with the graph of f. So I've gone ahead and drawn this out, and this is what I believe it to be looking like. So first it's decreasing concave down here, and then it's decreasing concave up, then it's increasing concave up, then increasing concave down, then decreasing concave down, and then finally decreasing concave up. And that's just by looking at the different points on this graph, noting where it switches from increasing to decreasing and positive to negative. And that's it for part A. Okay, this is part B. It says, pictured first is the graph of f of t. Which graph below, labeled a of x, is an accumulation function of f of t? When you're doing this type of problem, you have to have your extended table out for reference or have it memorized. I wrote it out here in a more simple way, and it's almost like a cheat sheet when doing these problems. The first thing you want to do is you want to find where the f of t graph has positive and negative area. This is pretty easy to spot because from 0 to 2.5, all this area under the curve here is all going to be positive, and we can represent that by filling it in there. Respectively, from 2.5 to 4, you have negative area because it's below the x-axis. And so what does this mean? Well, for the accumulation function, whenever f of t is going to be positive, the accumulation function is going to be increasing, and respectively, whenever it's negative, the accumulation function is going to be decreasing. So we can represent that by writing it out here and here. We're going to use that later to select from the given choices. So the second thing we have to do is look at concavity, and we do this by figuring out where the original f of t graph is decreasing and where it's increasing. So to start, you can see from 0 to about 1, it looks like if this were a hill, it's going downhill, and then it reaches the bottom of the hill right there where it's a flat spot. So we can say it's decreasing from 0 to 1. Then at 1, it's going to be increasing until 2 when it reaches the top of the hill and becomes flat again. So we can represent that by putting this here. Then from 2 to 3, it's going to be decreasing again. It's going down the hill. Then from 3 to about 3.8, we'll say, it's going to be increasing again with a little bit of decreasing at the very end. So we'll include that here. And so what does this mean? Well, whenever the original f of t graph is decreasing, it will be, the accumulation function will be concave down, and whenever the original function is increasing, the accumulation will be concave up. So now let's look at our options and rule out which ones won't work and which ones will work. So to start, we need a graph that is increasing from 0 to 2.5. Is this one increasing from 0 to 2.5? No, it's doing a zigzag, and that's not what we want, so we can rule out number 1. Is this one increasing from 0 to 2.5? Well, it's increasing, but then it starts to decrease before it hits 2.5. So there's only 3 options here. We can automatically rule out these 2, but for the sake of the problem, we will look at number 3 and decide whether or not it's actually what we want. So, is it increasing from 0 to 2.5? Yes, it is. And it hits a peak at 2.5, and is it decreasing from 2.5 to 4? Yes, it is. So now we can look at concavity. Is it concave down from 0 to 1? Let's see. Is it concave down from 0 to 1? Yeah, it looks like an upside down bowl. It is. So, that's correct. Is it concave up from 1 to 2? From 1 to 2, yeah, it looks like a regular upright bowl. And then it has an inflection point right here. And then it'll be concave down from 2.2 to 2 to 3 about. So from 2 to 3, it's concave down, yes. From 3 to about, let's say 3.8, it should be concave up. Yep, concave up. And at the very end, there should be another inflection point, and it starts to, if this were to continue, be concave down. And so 3 is the correct option. We're going to mark that here by putting a big circle around it. And that is that. Thank you.